When we talk about the exact value of the cosine of theta between two vectors, that's the phrase that we're looking for. The angle between two vectors, the exact value of the cosine of theta between the two vectors. That's this formula here. We're going to go cosine of theta equals A dot B over magnitude of A, magnitude of B. It's the dot product on the top and the magnitude of each of the vectors on the bottom. Now, as we look at these four problems here, okay, I just want to, at the beginning of this video, just kind of show you all my work there, all my work and all the answers for all of them. And then what I want to do, I think the ones that have the radicals in them are the more complicated ones. And so what I want to do is just work out two problems with you with the C and the D. Let's start with letter D first. Okay, we're given two vectors. I want to find the angle between the two vectors, or the cosine of theta between the two vectors. So those are my two vectors right there. So the first thing we need to do is the dot product. So if I do the dot product, A dot B, that's going to be 7, 2 dot product with -4, 3. So I'm going to go this times this plus that times that. So I'm going to go 7 times -4 plus 2 times 3. So that's going to be -28 plus 6. That's going to give us a -22 for the dot product, right? And then we're going to do magnitude of A and the magnitude of B. Remember, the magnitude of the vector is just the Pythagorean theorem. It's the square root of each component squared. So I'm going to do the square root of 7 squared plus 2 squared. And we need the exact answers on these things here. So that's going to be 49 plus 4, which is square root of 53. And then the magnitude of B, we'll do the same way. I'm going to do the square root of this thing squared plus this thing squared. So now when you square -4, it's -4 in parentheses squared. That's going to be, you know, like this, like -4 squared plus 3 squared. Always put that negative number in parentheses because you're going to get a 16 plus 9 there to get a 6 squared root of 25, which is equal to 5. So if you can break those down a little bit, get a perfect square, there you go. And then your formula, the cosine of theta equals A dot B over magnitude of A times the magnitude of B. You just multiply those two magnitudes together on the bottom. So our dot product here, so I'm going to have cosine of theta equals, the dot product on top is -22. On the bottom, we have the square root of 53, and then we're going to times that by 5. If you kind of simplify that a little bit, you can there, but I believe we could just leave that as -22 over 5 radical 53. Now, if you're going to deal with any sort of multiple choice, you know, check and see if that answer choice is right there. That is possible that might be there. If it's not there, you know, you can rationalize this. You can multiply the top and the bottom by the radical 53. So that'll give us -22 radical 53. On the bottom, you have 5 times radical 53 times radical 53 is 53. So 53 times 5 is going to give us 265 right there. So if you have to deal with multiple choice, if it's not multiple choice, we'll accept either or. But if it is multiple choice, you got to find the one that's there. Or maybe, you know, do the decimal answers of that, do the decimal answers of the multiple choice and see which one matches that decimal answer, and you'll be good there. And then that is what the cosine of theta is equal to. And that's what the directions are asking for, is what is that cosine of theta? And we did the dot product over the magnitude of those two vectors. So you're done. Now, if you ever have to in the future, like for college or something, actually find that angle, well, then you're going to do the cosine inverse of that number. That's going to give you the angle between those two vectors there. All right, and then let's do letter C. Letter C looks like a hard problem. So let's do this one together as well. All right, but we have our two vectors. So the first thing I'm going to do is do the dot product. All right, so there's my vector A, there's my vector B, and let's go through this process here. So if I do the dot product, I'm going to do this times this. So if I go 1/3 times 1, so I'm going to go A dot B equals, I'm going to go 1/3 times 1 is just going to be 1/3. And I'm going to go plus this times this. And so this is like over 1 here. So I'm going to go -2 over radical 3 times radical 3. Since both those are inside the radical, I can make that a negative radical 6. And I have 3 times 1. I have a 3 on the bottom. Now notice we have like a common denominator, one single fraction right there. So, or we already have a common denominator. So I'm going to make that 1 minus the square root of 6 all over 3. there's my dot product right there. And then I'm going to need to do the magnitude of A and the magnitude of B. So the magnitude of A is going to be the square root of the 1/3 squared plus the negative radical 2 over 3 squared. And so 1/3 squared, that's going to give us 1/9 plus, and when you take a negative number and square it, it's going to be a positive number. When you take a square root and square it, it just cancels it out. So that's just going to be a 2 over 9. And so that's going to be 3 over 9, but that's all underneath that square root. And that's going to be the square root of 3 on the top, and then the square root of 9, which is 3 on the bottom. So I get square root of 3 over 3 for that. And I'm also going to do magnitude of B the same way. I'm going to do the square root of the 1 squared plus the square root of 3 squared. So I'm going to go 1 squared plus the square root of 3 squared. And it's going to be 1 plus 3. That's going to be the square root of 4, which is equal to 2. And then when you do your formula, it's going to be cosine of theta equals, we're going to go A dot B over magnitude of A times magnitude of B. So the dot product looks a little weird there. That's why we're kind of walking through this thing together. The dot product is this funky thing right here. So we're going to go 1 minus radical 6 over 3. And then you're going to divide that. The magnitude of A is square root of 3 over 3. And then you're going to times it by the magnitude of B, which was 2. So here's what we're going to do. I'm going to make this 1 minus radical 6 over 3 on top. Now on the bottom, you're just multiplying these two fractions together. This is like 2 over 1. So if you smush it, you got 2 radical 3 over 3. All right, so now look here. You're going to go back to like your 3rd grade self. All you're doing is dividing two fractions. You have a top fraction divided by a bottom fraction. Remember, ever since elementary school, when you divide fractions, you multiply by the reciprocal. So I'm going to leave that top one alone. Now I'm going to multiply by the reciprocal of that second one. So I'm going to flip the second one, make that 3 over 2 radical 3. And then look, those 3's are going to cancel out, and you're going to be left with 1 minus radical 6 over 2 square root of 3. And that's our final answer right there. You're allowed to stop right there. When you have the binomial stuff with the radicals, you can just go ahead and stop right there. Now, if you look at my other 2 answers there, letter A was a lot easier. It was just nicer numbers and stuff to work with there. So I think you should be perfectly fine with that. Letter B was also like letter C, where you got a binomial for your dot product, and then you got 2 different magnitudes right there. And then notice you're just allowed to stop right there, and you can leave that radical in the denominator. Or if you ever have an issue with the answers, you could take all of the, if you got stuck, if you have everything and then you got stuck with how to simplify this, you could just take all of this stuff right here. If you are given a multiple choice situation, you could take all of this stuff right here, plug that into the calculator, take the answer choices, plug those into the calculator, and see which ones are matching up right there. But if it's a free response situation there, then we're just going to make sure we get that exact answer like that.